So let's start our whirlwind tour of Rails and its model view controller. We're going to more or less go in that order. So we'll start with the part that's actually the heaviest weight part, and I'll give you an introduction to ActiveRecord. ActiveRecord is actually a design pattern. It's not just the name of this library that's part of Rails. It's a way, like we said earlier, of thinking about how you connect in-memory objects that are instances of a Ruby class with the representation of those objects when they're stored in something like a persistent database. So the thing that ActiveRecord tries to answer for us is, how can we use some of the interesting language features we've seen, like reflection and metaprogramming, to simplify how this design pattern is provided to us and how it's implemented? And in this case, the design pattern in question is ActiveRecord, which bridges the gap between instances of a Ruby class that you've defined and their stored representation. So crud and SQL. Let's start out with some acronyms right away. The structured query language, if you've never heard the abbreviation SQL, most people pronounce it SQL, although I believe technically that is not correct, is a query language that is used by relational databases, which is probably one of the most important, if not the most important advance that computer science made in understanding how to organize and query and talk about the relationships among different types of data. In fact, Ted Codd received the Turing Award for his contribution of the relational algebra, which is a formalism for manipulating data. And the SQL language really is a way to instantiate the relational algebra in engineering terms and build engines that can manipulate data according to those rules. So the way ActiveRecord works is that Rails generates the SQL statements you need at runtime based on your Ruby code. And I'm going to use this icon to call your attention to the fact that this is one of many examples we'll see of code being generated at runtime. Sometimes at runtime, other times at compile time. But the idea of code that writes other code is pervasive in Ruby. We've already seen a little bit using things like method missing, where we can, and attr_accessor, where we can create new code at runtime. So this is another example. There's 4 things that you can do to a piece of data when it sits in a persistent storage system, and not just in a relational database, really in any persistent storage, right? You can create a new piece of data there. You can read data that is already in there. You can update something about an existing piece of data, or you can delete it. Now, we're not going to do very much raw SQL in this class, so we actually don't have to, but it is worth at least going through a couple of the SQL tutorials to see some of the basics and to get used to what it looks like, just because in some cases, like all abstractions, ActiveRecord is a leaky abstraction. Sometimes it doesn't work quite the way you expect, or sometimes because of your own misunderstanding, you might accidentally misuse it and not express the query you thought that you were expressing. So at some level, it is useful to be able to look at the SQL that was generated and say, oh, OK, that's why my query is not working. Here's a simple example of what creation looks like if you were writing it in raw SQL. Here, the assumption is users is the name of a table, and I'm going to insert into it values for at least these 3 columns, which are assumed to be part of the schema, columns in that table. And here's the values that I'm going to put into those columns. I've got one tuple, which is information about myself, and another tuple, which is information about Dave. So I've added 2 rows to the database. I haven't made explicit whether there's other columns in the table or not, but certainly I'm assuming that these 3 exist. I can also read from that table. I can say select, and the star means when you find rows that match my criterion, give me back all of the attributes associated with each of those rows. So select star from the users table where certain conditions are true. An example of a simple condition is birth date between 2 particular dates. There's many other ways that you can do matching things in SQL. I can update. I can say in the users table, do an update such that any user where the username equals Fox, you should substitute, you should set a new value for the email attribute to be this. And in some cases, if we assume username is unique in our example, then in this case, update would only affect a single row. But it's possible, and indeed Rails relies on the fact that you can write update statements that affect many rows. You have a collection of rows that match some criterion, and on each one of those rows, you're going to update in place one or more of its attributes. And finally, you can say delete from, and again, you can provide a variety of ways to match what the where condition is. So those are the 4 basic operations. We're going to use those as a starting point to talk about ActiveRecord. So we briefly discussed that the Ruby side of a model inherits from ActiveRecord base, and that's a way that you connect a model to the database. And among the many things ActiveRecord does is it certainly makes it easy to do those CRUD operations on the model. So let's switch over to a code view. OK, so here's a small chunk of Ruby code. And what have I done here? I declared a class movie that inherits from ActiveRecord base, and that's it. I have not put any code whatsoever into this class. Now, because you all know object-oriented programming, you realize that that doesn't matter because there is already a bunch of code in the class, so to speak. It's the code that its ancestor has, ActiveRecord base. So I'm just saying I'm going to create objects of class movie. They're going to inherit all of the behaviors of ActiveRecord base. And here's examples of some of them. I can create a new movie. And remember, when we see that, the capital letters for class names, movie.new, that means that new is a class method. That makes sense, right? You don't have an object yet, then you can't do anything to it. You need a class method to create the object for you. Once you've got the object, I'm assuming that it's got these attributes, title and rating. And what we're going to see in a minute is that rather than declaring in Ruby what the attributes are and then separately making sure you have a database table that matches, Ruby will actually infer what the attributes are by looking at the database table. So it saves you some typing. Another way that I could create a new movie is I could use the fact that new optionally takes a block, and it yields to that block the newly created object. So if I have to do some complicated initialization of the object, it's often easier to do this than to have a bunch of lines setting up individual things. So in Rails, another thing we're going to see a lot of, which is the handshake icon here, is convention over configuration, which means if you stick to certain rules for naming things, there's a bunch of work you don't have to do to tell Rails the correspondence between different types of objects. And in this case, the database table name is assumed to be derived from the name of the model. So if the model name is movie with a capital M, then the database table is lowercase movies, S plural. Why is it S plural? Well, because it stands to reason a table contains more than one movie. So a table called movie wouldn't make a lot of sense. It's just more satisfying to pluralize it. And in case you were going to ask, if you have a table, or if you have a model called person, does that mean that the table is called people? Yes, it does. And if your model is called sheep, does that mean that the table is also called sheep? Yes, there's a part of Ruby that just cares about how to pluralize words. It's called the inflector. But again, why is this? Because it makes sense, right? You have a movie, a table holds lots of movies. Very sensible. The database table column names become getters and setters for model attributes. This is really important because what we've seen so far is we defined using attr_accessor, for example, what we wanted the attributes to be. And what I showed you is when you use attr_accessor, the only thing that it really does is create like the world's simplest getters and setters, really just wrappers around setting instance variables. But now this is going to be different, right? And this shows you the benefit of why it's cool in some sense that the only access to a data object's attributes is through getters and setters. ActiveRecord defines getters and setters that actually work by talking to the database. So the way that you use these models in Ruby looks just like plain old models with attr_accessor, but the way that the implementation works is completely different. So as we'll see, the getters and setters don't actually modify instance variables, right? There is no underlying instance variable, for example, @title for a movie. Instead, there's an internal manipulation that Ruby manipulates and that Rails causes to be translated to the database. So how does this work? Well, we've created a new movie, but we haven't actually put it in the database yet, right? All we've done is create a new Ruby object and set some attributes on it. If we call save on that object, or save bang, or save, or whatever you want to call the other one, once you call that on the model, that's actually when the changes happen. That's when the database actually gets updated with the new attributes that you've set for that model. And remember we said before that when there's a bang on the end of a method name, it usually means dangerous method, use with care. In the case of the ActiveRecord methods that have bang on the end, it means that they raise an exception if they fail, as opposed to the non-bang methods, which just return nil if they fail, and you have to check. And which one is more appropriate to use depends on the context in which you're trying to do it. Now, once an object's been created, it acquires a primary key. Remember, we said that by convention, the primary keys of Rails objects are integers. There's an ID that is unique in the entire table. Obviously, before the object has been saved, it can't have an ID. It only acquires one the first time the database saves it. So if you have an ActiveRecord model and its ID attribute is nil, or if you call new record on it and you get back true, it means that that model has never been saved. You've manipulated it in memory. You have not actually saved it in the database. And all of these behaviors are inherited from ActiveRecord base. They're not things that are true of Ruby objects in general.